Hello everyone and welcome back to DevOps Basics with Dolly. I'm Dolly and in today's episode we're going to build our very first Terraform project using AWS. In the previous episode we installed Terraform and learned the basic workflow. Today we're going one step further. We'll create a real AWS resource, deploy it with Terraform, verify that it works, and then safely destroy everything. Along the way we'll use the official Terraform documentation, the AWS console, Visual Studio Code, and the terminal. By the end of this video, you'll understand the complete Terraform workflow from start to finish. So let's get started. Before we jump into the hands-on demo, let's take a quick look at today's roadmap. We'll start by creating our project and our first Terraform file. Then we'll visit the official Terraform Registry to understand what a provider is and how Terraform communicates with AWS. Next, we'll create an EC2 instance manually in the AWS console. I want you to understand what we're automating before we automate it. After that, we'll create an IAM access key, so Terraform can authenticate with our AWS account. Then we'll return to the documentation, find the EC2 resource, and use that example as the foundation of our project. Finally, we'll run the complete Terraform workflow: init, validate, plan, apply, and destroy. And at the end of the episode, you'll clearly see why infrastructure as code is much more powerful than creating resources manually. So let's get started. All right, let's start by creating a new project. I'll open Visual Studio Code and create a new folder called Terraform-Demo. Inside this folder, we're going to keep everything related to our first Terraform project. Now let's create our first Terraform file. This file is called main.tf. Most Terraform projects start with a file named main.tf. There's nothing special about the file name itself, but it's a common convention used by almost every Terraform project you'll find online. Right now the file is completely empty. In the next step, we'll visit the official Terraform documentation and start adding our first configuration. Whenever you're learning Terraform, this should be your first stop. AI is a great assistant, but the official documentation is always the source of truth. So let's open the Terraform Registry. The Terraform Registry contains everything Terraform can work with: providers, modules, resources, and their documentation. Every cloud platform or service that Terraform supports has its own provider. Since we're going to work with Amazon Web Services, let's search for the AWS Provider. This is the official provider maintained by HashiCorp. Think of a provider as a plugin that teaches Terraform how to communicate with a specific platform. Without a provider, Terraform wouldn't know how to create an EC2 instance, an S3 bucket, or any other AWS resource. Let's copy the basic provider configuration. Back in Visual Studio Code, we'll paste it into our main.tf file. This block tells Terraform that we're going to work with AWS. It also tells Terraform which AWS region we'll use. In this example, we're using US East, North Virginia, also known as US East 1. At the moment, that's all we need. Later in the series, we'll see many more provider options. If we tried to run Terraform now, it would know we want to use AWS, but it still doesn't know who we are. Before Terraform can create resources, it needs permission to access our AWS account. So the next step is creating our AWS credentials. In production environments, there are better authentication methods, but for learning Terraform, using an access key is the easiest way to understand how everything works. So let's create one. I'll create a dedicated IAM user for Terraform. It's important not to use the AWS root account. Following the principle of least privilege is always a good practice, even in a learning environment. Now I'll create a new access key. AWS will generate two values: an access key ID and a secret access key. This is very important. The secret access key is shown only once. If you close this page or lose the key, AWS will never show it again. In that case, you'll need to generate a new access key. So always store it somewhere safe. AWS has now generated our credentials. We can see both the access key ID and the secret access key. also gives us the option to download these credentials as a CSV file. This is useful if you want to store them securely and use them later. For this demo, I'll simply copy the values and continue. Once the key is created, if we go back to the Security Credentials tab, we can see that our access key is now associated with this IAM user. Notice that AWS only shows the access key ID. The secret access key is no longer available. That's why it's so important to save it when it's first generated. Before we create an EC2 instance with Terraform, let's create one manually. I want you to understand what Terraform will automate for us in just a few minutes. For this demo, we won't go through every configuration option. Our goal is simply to launch an instance and identify the information we'll need later in our Terraform configuration. First, let's give our instance a name. I'll call it Terraform-demo. The next step is choosing an Amazon machine image, or AMI. An AMI is basically the template used to create a virtual machine. It defines the operating system and the initial software that will be installed on the instance. For this demo, I'll choose the Ubuntu image that's eligible for the AWS free tier. Notice that every AMI has a unique identifier. This is the AMI ID. We'll need this value later when we create the same EC2 instance using Terraform. So I'm going to copy it now, and I'll paste it into our main.tf file as a comment. That way, we'll have it ready when we create our first Terraform resource. For the instance type, I'll select tdai2.micro, which is included in the AWS free tier. AWS also asks us to choose a key pair. Since we are only demonstrating how to launch an instance and we won't connect to it using SSH, I'll simply proceed without a key pair. That's perfectly fine for this demonstration. I'll leave the remaining options with their default values. Remember, today's goal isn't to learn every EC2 setting, it's to understand the minimum information required before we automate the process with Terraform. And that's it. With just a few clicks, we've created our first EC2 instance manually. But imagine doing this over and over again. Every time you need another server, you'd have to repeat the same steps. This is exactly the problem infrastructure as code solves. Now that we know what an EC2 instance looks like in the AWS console, let's go back to the official Terraform documentation and learn how to create the exact same infrastructure using code. The next step is finding the Terraform resource for an EC2 instance. We could browse through the AWS Provider documentation, but AWS has hundreds of Terraform resources. Sometimes it takes a while to find the one you're looking for. As you can see, there are a lot of resources available. If you're new to Terraform, scrolling through this list every time isn't the most efficient approach. Here's a small tip that I use almost every day. Instead of navigating through the documentation manually, I usually search directly in Google. Most of the time, one of the first search results points directly to the official Terraform documentation. Just make sure you're opening the page from the Terraform Registry, not a random blog or AI-generated article. Here we are. This is the official documentation for the AWS_instance resource. The documentation usually starts with a simple example. That's exactly what we're looking for. There's no need to write everything from memory. Even experienced DevOps engineers copy these examples from the official documentation and adapt them to their needs. I'll copy this example and paste it into our main.tf file. Now we have our first Terraform resource. Don't worry if some of these fields don't make sense yet. We're going to review them one by one. One of the biggest misconceptions about Terraform is thinking that you need to memorize every resource and every argument. You don't. The official documentation is there to help you. The important skill is knowing how to find the right resource, understand what it does, and adapt it to your project. That's exactly how professionals work every day. Before we customize this resource, I'd like to explain its structure. The good news is that almost every Terraform resource follows exactly the same pattern. Every resource starts with the resource keyword. That tells Terraform we're defining a piece of infrastructure. The second value is the resource type. This tells Terraform what we want to create. In this case, an AWS EC2 instance. You'll notice that the resource type usually starts with the provider name. Here it's AWS, because we're using the AWS Provider. Think of it like this. The first part identifies the provider, and the second part identifies the specific resource. Finally, we have the resource name. In this example, the name is example. This name exists only inside our Terraform project. AWS will never see this name. Terraform uses it to reference this resource from other resources later on. So every Terraform resource follows the same basic structure: the resource keyword, the resource type, and a local name. Everything inside the curly braces is the configuration for that resource. Now that we understand the structure, let's customize it for our own EC2 instance. The first thing I'm going to change is the resource name. Instead of using example, I'll rename it to Ubuntu_server. This name is only used inside Terraform to identify the resource. It doesn't become the name of the EC2 instance in AWS. Next, let's replace the AMI. Remember the Ubuntu AMI we copied earlier from the AWS console? That's exactly why we saved it. I'll simply replace the example value with our Ubuntu AMI ID. The instance type is already set to t3.micro. That's exactly what we selected when we created the instance manually, so we can leave it as it is. Finally, let's configure some tags. Tags are key value pairs that help us organize and identify our AWS resources. The name tag is what you'll typically see in the AWS console. I'm also adding an environment tag, a project tag, and a manage by tag. Manage by equals Terraform is a common convention that makes it easy to identify resources created through infrastructure as code. Even in small projects, getting into the habit of tagging your resources is considered a best practice. As your infrastructure grows, tags become essential for organization, automation, reporting, and cost management. Our Terraform configuration is ready. Before Terraform can work with this project, we need to initialize it. So I'll open the terminal and run Terraform init. Terraform reads our configuration and detects that we're using the AWS Provider. It then downloads the provider plugin required to communicate with AWS. It also creates the files Terraform needs to manage this project. The initialization was successful. Notice that Terraform created a hidden folder called .terraform. It also created a dependency lock file called .terraform.lock.hcl. This file records the provider version used by the project, helping keep the environment consistent. We normally run Terraform init when we create a new Terraform project, when we add or change a provider, or when we configure a new backend. It doesn't create any AWS resources. It only prepares the project. Now that the project is initialized, let's format and validate our configuration before creating anything. Our configuration has been validated successfully. Now let's see what Terraform is actually planning to do. I'll run Terraform plan. This command does not create any infrastructure. It simply compares our configuration with the current state of our AWS environment and shows us exactly what will happen if we apply these changes. The first thing you'll notice is this plus sign. In Terraform, a plus sign means a resource will be created. If we were updating an existing resource, we'd see a different symbol. And if Terraform planned to remove a resource, it would indicate that as well. In this case, we're creating a brand new EC2 instance. Here, Terraform tells us exactly which resource it's going to create. In our case, it's the Ubuntu_server resource that we defined in our configuration. Here we can see the AMI ID. This is the Ubuntu image that we copied earlier from the AWS console. You'll also notice many fields that say known after apply. These are values that Terraform cannot know yet because the EC2 instance doesn't exist. For example, the public IP address, the private IP address, the availability zone, and the instance ID. AWS will generate those values when the instance is actually created. After the deployment, Terraform will retrieve them automatically. Here we can verify the instance type. As expected, Terraform will create a t3.micro instance exactly as we configured. And finally, we can see all the tags that will be applied to the EC2 instance. This confirms that Terraform isn't only creating the resource, it's also configuring it exactly as we've defined in our code. At the bottom, Terraform gives us a very clear summary of the execution plan. 1 resource will be added, 0 resources will be changed, and 0 resources will be destroyed. Everything looks exactly as expected. Now comes the exciting part. We've reviewed the execution plan, Terraform knows what to create, and we've confirmed that everything looks correct. So let's go ahead and create our very first AWS resource with Terraform Apply. Before approving the deployment, here's an important DevOps tip. Always review the execution plan one more time before entering yes. Check the resource name, the AMI, the instance type, the region, and the final summary. Make sure Terraform is only creating, modifying, or destroying what you expect. Only the word yes will be accepted. So I'll enter yes and press enter. And we got an error. This is actually a great opportunity to practice some real troubleshooting. The first thing we should do is read the error message carefully. Terraform successfully connected to AWS and tried to create our EC2 instance. But AWS returned a 403 unauthorized operation error. Here, AWS tells us exactly what the problem is. Our IAM user, EC2-demo-user, is not authorized to perform the EC2:run instances action. This means our access key is valid and Terraform authenticated successfully. However, the user doesn't have permission to launch an EC2 instance. Authentication tells AWS who we are. Authorization determines what we're allowed to do. In this case, authentication worked, but authorization failed. Let's go back to IAM and open our Terraform user. Under permissions, we can see that this user doesn't currently have permission to manage EC2 resources. For this learning environment, I'll attach the AWS managed policy called Amazon EC to full access. This gives our demo user the permissions required to create and manage EC2 resources. In a production environment, we shouldn't automatically grant full access. We would normally create a more restrictive policy containing only the permissions required by the project. But for this beginner demo, we'll keep the configuration simple. Now that we've corrected the IAM permissions, let's return to the terminal and run Terraform Apply again. We don't need to change our Terraform resource because there was nothing wrong with the code. The failure happened before AWS created the instance, so Terraform can safely try again. Terraform is now creating our EC2 instance. This usually takes a few seconds. The exact time depends on the type of resource you're creating. An EC2 instance is relatively quick, but more complex infrastructure can take longer. Great. Terraform has successfully created our first AWS resource. Now let's verify that everything was created exactly as expected. We'll switch back to the AWS console. Here it is. Our new EC2 instance has been created. Notice that its status is still initializing. That's completely normal. AWS is still provisioning the virtual machine and running the initial startup process. After a short time, the status checks will complete and the instance will be ready to use. I also just noticed something. Both instances have the same name tag. That's because I accidentally used the same tag value as the instance we created manually earlier. I'm actually going to leave it like this for now. Later we'll change the tag in our Terraform code and see how Terraform handles an update to an existing resource. It's a great opportunity to understand how Terraform detects configuration changes. If we open the instance details, we can verify that Terraform created exactly what we described in our configuration. Here we can see the Ubuntu AMI, the instance type, the region, and all the other configuration values. And if we look at the Tags tab, we can see every tag we defined in our Terraform code, the name tag, the environment, the project, and manage by equals Terraform. None of these were added manually. Terraform created them automatically as part of the deployment. At this point, we've successfully deployed our first AWS resource using Terraform. But infrastructure as code isn't just about creating resources, it's also about managing changes over time. So let's make a small modification to our configuration and see how Terraform detects and applies that change. Now let's see one of Terraform's biggest advantages. Instead of creating a new EC2 instance, I'm only going to change the name tag. I'll add a 2 at the end, so it's easy to identify the change. Let's save the file and run Terraform apply again. Before I approve the changes, let me show you one more useful option. Instead of waiting for the confirmation prompt, we can run Terraform apply --auto -approve. This tells Terraform to skip the approval step and apply the changes immediately. For this demonstration, I'll use --auto -approve so you can see how it works. However, in the next episodes, we'll go back to the normal workflow and review the execution plan before every deployment. Before Terraform makes any changes, it compares our current configuration with the actual infrastructure running in AWS. This comparison is what allows Terraform to detect exactly what has changed. Notice that this time we don't see a plus sign. Instead, we see a tilde. In Terraform, a tilde means the resource will be updated in place. In other words, Terraform isn't going to create a new EC2 instance, and it isn't going to destroy the existing one. It's simply going to modify the existing resource. Here we can clearly see the change. The name tag currently has the value Terraform-demo, and after the update, it will become Terraform-demo2. The update completed successfully. Let's go back to the AWS console and verify the result. After refreshing the page, we can immediately see that the instance name has changed to Terraform-demo2. And if we open the Tags tab, we can see that the name tag has also been updated. So far, we've learned how Terraform creates new infrastructure and how it updates existing infrastructure. The final step is just as important. Let's see how Terraform can safely remove everything it created using a single command, Terraform destroy. Just like with plan and apply, Terraform first shows us exactly what it's going to do. This time, notice the minus sign. In Terraform, a minus sign means the resource will be destroyed, and the summary confirms it. 0 resources to add, 0 resources to change, 1 resource to destroy. Just like Terraform apply, Terraform asks for confirmation before deleting real infrastructure. This is an important safety feature because deleting resources cannot be undone. Everything looks correct, so I'll confirm the operation. Terraform has successfully destroyed the EC2 instance. After refreshing the AWS console, we can see that the instance is now being terminated. In a few moments, AWS will remove it completely, and that's the complete Terraform lifecycle: create, update, and destroy, all from a few lines of code. Before we finish, let's see one practical example of how AI can help us during our daily work. Earlier in this episode, Terraform returned an error because our IAM user didn't have permission to create an EC2 instance. Instead of spending several minutes searching through the documentation, let's ask AI for help. Notice that I didn't ask AI to write Terraform code. I'm asking it to help me understand the error. That's a much better use of AI in my opinion. AI correctly identifies that this isn't a Terraform problem. Terraform authenticated successfully. The problem is that our IAM user doesn't have permission to perform the EC2:run instances action. It also suggests attaching the appropriate IAM policy, which is exactly what we did earlier. This is how I recommend using AI as a DevOps engineer. Use it to understand errors, interpret documentation, and speed up troubleshooting. But always validate the solution before applying changes to your infrastructure. Before we finish, let's do a quick recap. Today, we learned what Terraform providers are and how to configure the AWS provider. We created an IAM user with the permissions Terraform needed to interact with AWS. Then we followed the complete Terraform workflow: init should plan, apply, update, and destroy. Finally, we saw how AI can help us troubleshoot faster while keeping the official documentation as our primary reference. In the next episode, we'll learn about Terraform resources and dependencies and see how multiple resources work together in a real infrastructure. If you enjoyed this episode, don't forget to like the video and subscribe to the channel. The complete source code is available in the GitHub repository linked in the description. Thanks for watching, and I'll see you in the next episode of DevOps Basics with Dolly.